Question 5 about torque also. Complete the following statement. The moment of force about a point is multiplied by
the moment of force is a point
is
the force multiplied by the distance from the force to the pivot.
More accurately, the perpendicular distance. Later I show you a video and explain why we have to take the perpendicular distance from that point to the force. The reason it is called the perpendicular distance is as follows. We start an investigation about the balance of a lever. Okay, lever. We put the two objects, like here, 10 kilogram, and another object here at half a distance of 20 kilogram, and they are balanced. Okay, or instead of putting an object, we exert a force. So there's a force pushing this balance downward. That force is about 100 Newton. Okay. Not 10 kilogram, but assume that the force is 100 Newtons. And the distance from this force to the pivot here, this distance is 2 meters, for example. So to balance this, we need another 100 Newton force here at the same distance of 2 meters also, and the same force, 100 Newtons. Okay, or we can put another force here with the magnitude of 200 Newtons, and the distance is 1 meter. Okay. We do this thing by the experiment, the real experiment. But if we exert a force in the other direction, for example, at this position, but not in the vertical direction like this, but in this direction, the product of the moment here, 100 multiplied with 2 meters, we need a force F here, which is not 200 Newton, but greater than 200 Newton. Okay, so let me draw that even longer. The force here, if you exert it not in the vertical direction, but to the left like this, the force here must be greater than 200 Newtons. Okay, and if we measure the distance from the pivot, the perpendicular distance here to this one, for example, 0.5 meter. Okay, that force will be equal to this product, 200 divide that distance, 0.5, meaning 400 Newtons. Okay, so we discover the rule F1 D1 equal F2 D2 when the distances here, D1, D2 are the perpendicular distance, not the simple distance from the pivot to the force, not this distance, okay, but this perpendicular distance. We can see an experiment here to see that demonstration. So here,
which is suspended,
we have a force hang, an object, a weight hang here, for example, 10 Newtons. Okay, a distance, for example, 30 centimeters from the pivot here, and then we have another string attached to this point, okay, on the left, making an angle, and of course we can use a protractor to measure this angle. Okay, and then we have to adjust the weight of this object so that the system is in equilibrium, and then we will do the calculation, and we see that the product of the weight on the right here with the distance to the pivot, for example 10 Newtons multiplied with 30 centimeters, will be the same as the weight of this object multiplied with the distance drawn from this pivot in the perpendicular direction to the rope. Okay, this distance, not this length. Okay, there here he's talking about that distance. He making a perpendicular, a right angle here. Okay.